Next problem. We are back again and we have the next problem for this problem which we solved on, I don't know the date, but it was somewhere like on 13th of November. We solved a problem called populating the next pointers in each node, and in that problem we were given a perfect binary tree, and what we needed to do is just populate the next pointer for each node. Now we are on the part 2 of the same problem, and what we are given is a binary tree. It's not a perfect binary tree, hence you can see that, oh, its left child is missing, but in this question it wasn't missing. So it's basically the same solution. No, it is not. It is completely different solution. However, we can use this solution if we want to check to do to complete this solution. But why not learn some better approach? Why not do a better approach? So before going to this code, I have declared a few pointers here which I'll be needing to explain. So that's why I'll be taking help of my paintbrush to explain you this problem in a better way. I need this image, and let's see if I can. No, I cannot. I need to download this image. It'll only take a minute, like to download this image and then to open this image up here. Yes, I have my image. Now I can't move it, so sorry. Let's move my face. Yay. Now I have this problem where what I need to do is I need to make its next pointer point to its right next sibling. But if there is not a sibling, I simply need to make it point to a null variable, which it will already do. If its left sibling is missing and I make it point to here, it won't populate. It will automatically take up the null pointer. But the issue here is, what if my tree is somewhat like this? These are all the children, yeah, and this and this. I don't know why my circle looks more like a square, but yeah, it's okay. And then this, and then this. Now what I need to do is I need to make this pointer's next pointer point to this pointer's next pointer point to this, and this pointer's next pointer point to this. If you will look for my first approach, what I did is I just checked if it's not null, just make it point to its next. And if the next of my sibling is not null, for example if I am here, so its next is already at 3 because I have already populated it. Now what I need to check for my 5 here is if my parent's next pointer is not null. In this case it is not. Then what I will do is I simply need to make my roots rights next to point to the roots next left. Roots rights next point to the roots left next left. So 5 will point to 6. But here the main issue is that 6 might not exist. So my 5 needs to point to this 7 instead of that 6. Now how do I what do I do now if I have such a problem? I thought of different ways, but let me do this and this. Yeah, it's okay. So now what I'll be doing is I'll be iterating these levels. Instead of using a queue or recursion, I'll be iterating them like a linked list, because these are connected. Imagine that I have already connected this level. Now what I'll do is I'll iterate its next level, this 4, 5 and 7, and each time I'll maintain 3 pointers, which is my current pointer. If you can read Arabic, I'm sure you can read this. My previous pointer and my next head pointer. So let's take this case. This is the root right now that's given to us, yeah. So now what I'll do is my head is here. Let's not go into that how my head reach here and what's that. My head right now is here, and I'm iterating over the loop I am iterating over this, oh sorry, this loop here. My first, what I did is I created a head pointer which I made it equal to root. Then what I did is I created, I'll iterated over the head pointer unless it was equal to null. But unlike a linked list, this is not the linked list loop. This one is the linked list loop. So let's forget about the head right now. What I'll be doing here is I'll be at, if I'm at 4, I'll be going to 5. If I'm at 5, I'll be going to 7. But right now I am at 2. So at 2 I check if if 2 has a left child or not. If it does have a left child, now my 2 is right now my current as well as the head. So this was my head. I made my current here. I made a current pointer which is equal to my head. Yeah, if you can see this, I made a current pointer which is equals to the head. Now what I did here is I checked if the current's left child is there or not. If it is there, then there are only few cases, like my previous can or cannot be null and my next level pointer can or cannot be null. Before going into this, let me describe you what the next level pointer is. For this level, let's name it 1, 2 and 3. Right now I'm at the third level. Sorry, right now I'm at the second level, but how did I reach here? I needed some pointer which pointed to this 2. So I named it the next level pointer, or right now I'll be writing it as n. So when I was at 1, what I made is I made its left child. I check if it has a left child or not. It sure does, and I knew it was the first pointer of the next level. If you can see, it's the first node of the next level. Then I made n equal to this. So when I'll be iterating down the next level, I'll be helped by this. Now where was I? Right now I'm at 2. I checked if 4 is present or not, and also I check if this is empty or not. Right now, since we are on the next level, we are just starting the next level, we don't have a pointer for the next level, so we'll populate this pointer by 4. So now it will hold the address of 4 for us. And what I do is I check if the previous pointer is null or not. Again, hence since this is the first node of the next level, our previous node, we don't have a previous node. You can see there is nothing to the left of this 4. So what we do is we also make this equal to this 4. Now it has a 4. Now what I do in the same loop is I check if it has a 5, if it has a right child or not. If it does have a right child, what I need to do is I need to I need to populate the pointer for the 4th number to this right child. Now what is pointing to my 4th? This previous node is pointing to my 4. Now what I'll do is I'll check if 5 exists or not. If it does exist, what I'll do, I'll populate the previous's next pointer to be equal to this next pointer. Let me explain you with the help of this code. Now it will be much easier to understand. I'll also give you one more example if it is anyhow difficult. I created a current node which is equal to my head. I created a next level head which is right now a null, and I created a previous node which is also a null pointer. If you could see my board there, I did all the solvings there. I have a, I'll try to post a picture of this too. Now what I have here is my first node where I'll be iterating my tree like a linked list. This is my first loop. What I'll check is if it is not equal to null and the condition is make it equal to its next pointer. Now I'll check if it has a left or not, and if its left exists, then if is the next pointer null or not. What this question is this the first node of the next level? If yes, make it the next level head. If no, do nothing. Again, if the previous node exists or not. If it does, of course, populate the previous node's next pointer to be equal to this, but if it does not, just make the previous node equal to this. Same for the right. Why do I need to check it for the right? What if I have a tree which does not have a left child? For example, if this is my tree, so again, right now my this node, if instead of 4 we have nothing here, so I need to check for the right node also here. So what I need to check if it is the first node in my level or not. If it is, make it the head of that level. Then again, if the previous node exists or not. It will only not exist if it is the first node of my level. Otherwise it will most definitely exist. If it does not exist, I think we can merge these two conditions also, but let's not. If I don't have a previous node, just simply make it equal to the right. Or if I do have a previous node, what I need to do is I need to populate its next to be equal to current's right. Then I move to the right, and then I move to the next level. Let me explain you with this example here. This right now I am here, my current is here, my head is also here, my root current, all are at the same thing. Now what I'll be checking is if it has a left child or not. Sure, it does. So what I'll do is my n will be equal to this left child. Now I'll be and hence since my previous is null, I'll also make my previous point here. Again, I'll check if my right child exists or not. Yes, it does. Then I'll check if n exists or not. Yes, it does. Then I'll check if p exists or not. Yes, it does. If p exists, just make p's next node equal to this. I did. Again, now I make my head, which was here, to be equal to the next level head. Now my head is here, and we forget about this, the upper levels. Now we are only concerned about the lower levels. Now this is the head, and I need to iterate its lower level. Now again I'm here. My current is equal to head here, and my head is here. Although the root is here only, I don't care about the root. Now my what I need to do is reset my previous and next. Here, let me show it in the code. Yes, here each time my previous and my next are being reset to null. So I'll be resetting my previous. Go away, you too. So I only have an head here. Now I'll check if the head has a left child or not. Yes, it does. Is my n populated? No. Populate the n. Is my p populated? No. Populate the p. Now let's check for its right child. Does it have a right child? No, it does not. Now do nothing if it does not have the right child. Just make the current equals to the next of the current. So now my current is here. Check if it has a left child or not. No, it does not. Check if it has a right child or not. Yes, it does. Now check if n exists or not. N does exist. Check if p exists or not. P does exist. If p exists, just make it equal. P's next must point here. This is as simple as it looks. This is the easiest solution that I came up with, and we are only traversing the tree once, so its limit, its time complexity is also n, and since we have only taken 3 pointers, its space complexity is also constant, like it was mentioned here that we should try to do it with constant extra space. And although recursive approach was fine, but the recursive approach would require a huge amount of if and else, and I found this one the easiest approach, and it was accepted. Like, it was my solution, and if I found a better solution, I'll be making this video again. But till then, bye bye.